Yesterday, we started the parametric equations. What I talked about yesterday was, let's say this is a parametric curve, then that is a map from the interval in the real number line. And when we describe parametric curve has initial point and terminal point. And there is a parameter t. And in the real number line, there is a direction. And so when we trace the image of that parameter, we can think about the direction. It doesn't have to go to one direction. It can go this way and that way, and it can turn direction, but there is a direction. So the key point is to define parametric curve. We need two parametric equations. And parametric curve has trace, direction, and speed. Could you please use webcam and make your appearance visible? As I said, if you don't do that, then I may go too fast because I cannot see whether you're following. Let's do examples. What curve is represented by the following parametric equations? The given parametric equations are x equals cosine of t and y equals sine of t. T is between 0 and 2 pi. Yesterday, we used the elimination of parameter method. We will apply the same method, but differently. X is cosine of t and y equals sine of t. So what we can think about is if we think about the Pythagorean formula, then we can eliminate t. And we can create the equation which involves only with x and y. The Pythagorean identity was cosine squared of t plus sine squared of t equals 1. So cosine was represented by x, so x squared, plus sine was represented by y, so y squared equals 1. What we realize is this is the equation of a unit circle with a center 0, 0, and radius 1. By applying Pythagorean identity, what we realized was a given parametric equation. The trace of the parametric equation is indeed a circle with a center 0, 0 and radius 1. However, when we consider the parametric equation, it has speed and direction together. So we have to think about the direction to finish the problem. So we can draw the trace of the parametric curve like this. And we want to think about the direction. So what I will do will be, I will just evaluate at 0, pi over 2, and 3 pi over 2, and 2 pi will become 0, and it will repeat the pattern because we are thinking about the periodic function. So it is enough to evaluate only at those points. Let me put pi here. And then x was defined as cosine. So cosine of 0 equals to 1. And y was defined as sine. So sine of 0 equals 0. And the cosine of pi over 2 is 0. And sine of pi over 2 equals 1. And cosine of pi equals minus 1. And sine of pi equals 0. And the cosine of 3 pi over 2 equals 0. Sine of 3 pi over 2 equals minus 1. So what you have to remember clearly is the graph of sine and cosine. This is y equals sine of x. This is pi over 2. This is pi. This is 3 pi over 2. The maximum is 1 and minimum is -1. The other graph you have to know from the trigonometry course is the graph of cosine. It looks like this. It starts at the maximum and then continue with obvious wave pattern. And I use that to evaluate this table. So x value is 1, y value equals 0. So it starts here. And then when the angle is pi over 2, cosine of pi over 2 is 0 and sine is 1. So it goes here. And then x value is -1, y value equals minus 0. And then it goes like 0 and -1. So this point. So obviously, it'll trace the circle counterclockwise. So by doing this example, we could see that in the parametric curve, not only trace, there is a direction. However, you cannot feel how the speed is reflected in the equation. So what I want to say is the similar pattern of the parametric equations will result in the same circle and same direction, but the speed will be twice more than the original one. So the parametric curve x equals sine of 2t and y equals cosine of 2t. When we think about 0 to 2 pi has the same trace and direction. The reason is obvious because when we think about the Pythagorean formula, as long as these angles are the same, we can apply the Pythagorean formula. So it will satisfy the same Pythagorean formula. And so we will have x squared plus y squared equals 1. That means the trace of this curve is the same as this one. But because of this 2t, the speed is obviously faster than the previous one, right? I don't have to check it because that is too obvious. So this is an example. The curve, parametric curve, has different equation, but has same trace and same direction. The only difference is the speed. Any question about this? Can I move on? Consider x equals e to the 5t and y equals t plus 4. First one is find a Cartesian equation of the curve. If you want, then you can solve the equation by using y equals t plus 4 and then plug that into x. But usually we are more accustomed to the type of equation which start with y equals. So what we want to do is we want to start it with x equals e to the 5t. And then we will take natural log on both sides. What we know is a log base a of a equals 1. And log base a of a to the n power equals n, just this one. So what we know is a natural log means log base e and e to the 5t power. And that is natural log of x. So the right side becomes 5t, right? And the left side is natural log of x. So t equals natural log of x over 5 by dividing by 5 on both sides. Right, that is t. So we will put this into y equals t plus 4. Then we get y equals natural log of x over 5 plus 4. What we remember from the college algebra class is when we have y equals natural log of x, the graphical pattern looks like this. X-intercept is 1, and there is a vertical asymptote that is y-axis. If you look at the equation here, 4 plus 4 means a vertical shift up 4 units. And this one, so this 5 means the vertical shrink, vertical compression. So obviously it doesn't change the vertical asymptote, but graph will shift up 4 unit, and the graph will increase slower than the original one because we divided by 5. But we have to do one more thing. We have to figure out the direction of the curve. So we will make a chart. This is t. Let's say this is 0. This is 1. X equals e to the 5t. And y equals t plus 4. What's important to look at here is this is an increasing function. And this is also increasing function. It doesn't go increasing and decreasing, and pattern doesn't change. And so once we pick 2 points and we identify the direction, then the direction doesn't change. It doesn't go to the right and left. It just go to the right if that was the starting pattern forever because of this monotonicity. X equals e to the 5t power. So we plug in 5, 0 here, and then that is e to the 0, which is 1, and e to the 5 times 1 equals e to the 5th power. And when t equals 0, 0 plus 4 equals 4. And when t equals 1, 1 plus 4 equals 5. So We know this is a vertical asymptote, and we know that when x equals 1, y becomes 4. And when x becomes e to the 5th power, y becomes 5. So this is a vertical asymptote. It should pass through the 2 points, and the direction is obviously like this. This is the image when t equals 0, and this is the image when t equals 1. So that's the reason direction goes like this. Any question? The next question is consider x equals natural log of t and y equals square root of t. We assume that t is greater than or equal to 25. Find a Cartesian equation of the curve. We will have the same strategy since we prefer to have y equals something. Instead of squaring both sides, we will solve for t with the equation x equals natural log of t. X equals natural log of t, and we know that means natural log of e of t. By the definition of the logarithmic function, the meaning of this is e to the what power will make t. So based on this equation, e to the x power makes t. So t equals e to the x power. So we want to put this one into this equation. Then y equals square root of t will be written as square root of e to the x. And then that can be written as e to the square root is 1/2 power, so x over 2. Second question is sketch the parametric curve. What you notice is y equals square root of t. So, and t starts at 25. So when we pick the next point, maybe it is better not to choose like 26 or 30 because we have to calculate square root of that number. So this is 5 to the second. And so I will go with 6 squared, which is 36. And x is defined as natural log of t, and y is defined as square root of t. Let's calculate. When we plug in 25, the first one is natural log of 25. The next one is square root of 25, which is 5. And the next one is 36. And so that is natural log of 36. And so square root of 36 equals 6, right? Again, the reason I picked only 2 points to denote the direction is because this natural log function is increasing function. And this square root function is again increasing function. And so once we decide the direction with 2 points, the pattern will not change because that is a monotonic function. What we know is t start at 25. When t equals 25, the image goes to this point. And when t equals 36, image will become this point. And y equals e to the something power. What we know is a y equals e to the x power. That graph looks like this, right? So it'll follow the exact pattern. So it starts from here and the graph will exactly look like this. Just the increasing function with this direction. Any question? The next question is about sketch the curve with parametric equations. X equals 2 sine of t and y equals 4 sine squared of t. We still have the trigonometric function like in other problem, but this time the pattern of the problem is a little bit different because one uses sine and both are sine related things. But if you look at the equation here, then we can write sine of t equals x over 2. So what we can imagine is y can be written as an equation of function of x. So y is given as 4 sine squared of t. That just means 4 times sine of t squared. So that is 4 times x squared over 2 squared, which is x squared. That implies the equation we are getting is y equals x squared. However, what you have to be really careful in this case is this is not really y equals x squared entire graph. Instead, it is only the part of the graph. The reason is we are using sine function. So, and we know that sine function is bounded by -1 and 1. Sine of t is between -1 and 1. We know that this is the sine functions graph. So graph is bounded by -1 and 1. So what we know about x is defined as 2 times sine of t. So x is bounded by -2 and 2, right? We just multiply by 2 on each side to get the lower bound and upper bound of x. Any question? And we want to do the same reasoning for y. We start with sine is between -1 and 1, but y has sine squared. So we start with sine squared. Sine squared is always non-negative number, which means that should be greater than or equal to 0. But when we square 1, we get 1 again. So sine squared is also bounded by 1. Then we want to talk about y. Y is defined as 4 times sine squared of t. So we will just multiply by 4 on each side. Then that is 0 and 4. Right, so by using the maximum and minimum, we could get the maximum and minimum point for x value and y value. The Cartesian equation we already obtained is y equals x squared, right? And so we will use this one. Let's so what I will do will be I will draw the parabola first. 1, 2. It passes 0, 0 when that is 1. X value equals 1, y value equals 1, and when x value equals -1, y value is also -1. So the parabola will look like this. It doesn't stretch to the right and left. It is the clear endpoint. Different from other examples we have been discussing, in this case, the direction will not be just one direction. It'll go back and forth forever. That's because our sine function is increasing here and then decreasing here and increasing here and increasing, decreasing happens alternatingly. So what you can guess is probably it'll go to one direction and then the other direction, and just as it'll switch the direction regularly. So we want to think about the pattern by drawing the chart. Let's evaluate in one cycle of sine. So x equals 2 sine of t and y equals 4 sine squared of t. The first one is 2 times sine of 0. That is 2 times 0, which is 0. 2 times sine of pi over 2 is 2 times 1, which is 2. 2 times sine of 3 pi over 2, that is 2 times 0, which is 0. No, it is pi. It is -1. This pi, sorry, I keep missing pi, the 3 over 2. And then 2 times sine of 3 pi over 2 is 2 times -1 equals -2. And then 2 pi, then we go back to here. So we have 0 here. This time we have 4 times sine squared of t. So basically, this is the square of this one. But anyway, so this one is 2 times sine of t squared, right? So we just square this 0, 4, 0, 4, 0, right? So what we want to do is we want to think about the direction. When t equals 0, it was 0, 0. So t equals 0, it starts here. And when t equals pi over 2, x equals 2, and y equals 4. This happens when t equals pi over 2. So it moves toward this direction. And then when it becomes pi, x equals 0 and y equals 0. So, and then it moves back to here. And that happens when t equals pi also. And then when t equals 3 pi over 2, x is -2 and y equals 4. So it travels this direction and reach there. This one is when t equals 3 pi over 2. And then when t equals 2 pi, it moved back to here, right? And then the pattern will be the same because sine function is a periodic function. So when you observe the pattern of the function for one cycle, it is enough to understand the whole pattern of the function because it'll repeat the pattern over and over again. So it'll oscillate back and forth along the parabola. Any question? All right, then we will see tomorrow. If you don't have any question, then you can leave. Otherwise, you can remain and ask a question.